Hello students, welcome to Fun Maths Club. Last class we learned about sector of a circle. Also we learned uh, how to find the arc length of a sector of a circle, and we came to a conclusion that means if we have this formula we can find the arc length of a sector of a circle. So let's move to our examples here in the page number 6. So example 1, here you have a circle and the angle at the center is 45 degrees here. Also radius is equal 7 centimeters. Our first question is, what fraction of the circumference of the circle in the figure is the arc length of the shaded sector? So we know the angle at the center is 45 and the angle of the circle is 360 degrees. So 45 divided by 360 would give 1/8. So you found the fraction. Let's move to second part. So we have done part 1. Let's move to part 2. Find this arc length. So you are going to find the arc length. That means you are going to calculate this length. Okay. So let's move to this. See here, arc length, the angle proportion is 1/8 times 2 pi r. We know the circumference of the circle of this circle is 2 pi r. Here r is 7 centimeters, so here you have written 7 centimeters, and we are going to substitute 22 upon 7 instead of pi, so that's what we have written like this. Okay, and 2 here. So after you solve everything, you would get 5.5 centimeters. So the arc length of this circle is sector of the circle is 5.5 centimeters. Okay, let's move to example number 2. Here the arc length of the sector in the figure is 44 centimeters. So that means arc length from here to here is 44 centimeters. Okay, we can continue to read this question. Find the radius. So you are going to find you have to find the radius of the corresponding circle. So we know the formula is arc length is equal angle proportion times 2 pi r. Here we don't know r, right? So let's write it r here. But you know the angle length, it's given to you, it's 44 centimeters, right? So you can write 44 over here. The angle at the sector is 120 over the angle of this circle is 360 degrees. Okay, then times 2 pi r. instead of pi you can write 22 upon 7 times r, that we don't know, we have to find this value. So just write this r, just a notation, then substitute everything, then make r as a subject. You can move, you can let's do this one here. So keep this r as it is, okay, this side, and let's move this one to that side. So you can make it upside down when you move this one to other side. Let's write 44 as it is without changing. Make this one upside down, 7 over 22 times this one also. When you move to this one to other side, you can make it upside down, that is half. Shall we rewrite this? 44 times 7 upon 22 times half, and if you solve this one you would get 1 over 3. When you move to other side, this will be 3 over 1, that is equal to r. Okay, so let's rewrite this. 44 times 7 times 3, we don't need to write this one. Also you can write 22 times 2. Even if you write this one over here, no point of writing times 1 here, because whatever the number you multiply by 1 you would get the same. So when you look at this, that is equal to r, right? So when you look at this, that is here, right? So 44 upon 2, 44 times 3 times 7 upon 22 times 7, or 2 times 22, all are here. Let's erase everything. Okay, so look at this. 44, we can solve this. How many 22s are here? 2, so that's what I have cut this one. So then 2 cancel out, 1 times 3 times 7 is 21. So the radius of the circle is 21. We found the value of the r, it's 21. So hope this one is clear to you all. So let's move to example number 3. In this question, you have to find the angle at the center. An arc length of the sector is given, which is 11 centimeters. So from here to here to here, it's 11 centimeters. So you have to find the angle at the center. Let's write theta. So apply this formula. Arc length is equal theta over 360 times 2 pi r. Here the radius is 9 centimeters. So you can substitute 9 here. Instead of pi, you can write 22 upon 7. Write theta, and arc length is 11 centimeters, right? It's given to you. So you can write 11 centimeters and make theta a subject. Then you can find the theta. Okay, you would get angle at the center is 7, you would get the angle at the center which is 70 degrees. Okay, so hope this one is clear to you all. It's series. Okay, so now look at this. In the first example, we learned how to find the arc length of the sector. Okay, in the second example, we learned about the radius of the circle. Okay, so this part R. Okay, in the third question, we learned how to find the angle at the center. Okay, so now you know how to find angle at the center, radius, and the arc length of the sector of the circle. Okay, now let's move to exercise 1.1 under page number 7. So please try these questions and watch my next video to find the answers. Thank you for watching. Have a good day ahead.